Okay, so here we are going to talk about IO instruction. So here if you see, with programmed IO, there is a close correspondence between the IO related instruction that the processor fetches from the memory and the IO commands that the processor issues to an IO module to execute the instruction. Okay, I think you didn't understand anything. So here it means that programmed IO, we know it is a method where the CPU is directly controlling all the IO operation. Now here, what does this close correspondence means? Close correspondence means that when CPU is fetching an instruction, like this is an instruction, that is it has to read from port 60H. Okay, reading from 60H. Okay, that is what this instruction means. Okay, so from memory, the CPU is fetching an instruction like this from the memory, and it is translating that into a real hardware command, and then it has to send to the IO module, right? So there is no intermediate layer. The instruction the CPU reads is essentially the command that's getting executed. So the CPU is fully in charge. It wait and watch the IO operation until it completed. This is called as busy waiting or polling. So here we have understood what we know in programmed IO. We have understood that the CPU is actually what it is doing, that it will fetch an instruction which is related to IO. So here if you see, this is an instruction. This instruction itself means that you have to read from port this. So that means I have to read this from port, and I'm fetching this instruction from memory. So CPU itself fetches this instruction from memory, and it will translate, CPU itself translate that into this hardware command. It will translate this instruction to a command, and it will send to the IO module. So there is no intermediate layer that is happening between this. The instruction the CPU reads, that is this instruction the CPU read, is becoming the command here that is getting executed in the IO module. So that means CPU is the fully charged here. It waits and watches the IO operation until it completes this command. It has to wait there. This is busy polling. This we know. So here this sentence just means the same thing, but here the instruction the CPU fetches from the memory is directly transferred to the IO module like hardware command. So the same instruction is acting the command here, that is getting executed in the IO module, right? So what happens in programmed IO is that there is a close correspondence between the IO related instruction that the processor, that means this instruction that is the processor fetching from the memory, that is this instruction is close correspondence, means it is kind of same, that is to which the command the processor executes. Okay, it is close correspondence with the IO command that the processor issues to an IO module to execute the instruction. It just means, this sentence just means that the instruction here, the instruction that the CPU is getting, this instruction the CPU is getting from where? Okay, from this instruction the CPU is getting from the memory. CPU is fetching this instruction. Now this instruction is means, one example of the instruction is given, that is read from port 68. Okay, that is what this instruction means. This instruction is directly converted as command, hardware command. So that means this instruction and the command that you're sending to the IO to get executed is closely correspondent. It's kind of same. There is no difference in here. That is what it's saying. There is no intermediate layer between this instruction and command here. The instruction that the CPU is reading from the memory is the same. It is actually the same, the command that is getting executed in the IO module. That is what this means. This statement actually means. Fine. So on that understanding, let us see here more detail about these things. That is, the instruction are easily mapped to IO commands. So that means, we are talking about what kind of IO instruction and command things we are talking about here. Fine. So here if you see this IO instruction, software instruction, like in AL port means we are reading the data from the port, from that port or device. Port means the device we are reading the data. Here we are writing the data to that port. Okay, that is what this instruction means. Okay, these are the different kinds of instruction here. Now hardware command, what this is the instruction that would be converted into hardware command. How it is easily understood is like this, that is when it sees an instruction like this, that means we are reading the data from port, this hardware command would be given. Now here it means we are writing the data to the port, this hardware instruction command would be there. So that means this is how the instruction, the software instruction is converted, or it is easily mapped to this IO command. This means that the translation from the software instruction to hardware command is straightforward and direct. The what do we mean by this? That itself is the hardware command. As you see here, by reading this instruction we will understand that okay, I have to read from port, or port, that is this port I have to read, that means it's a device. So the hardware command is the same meaning, that is this what this instruction means, the same meaning is that. Okay, so there is no complex conversion that is happening, that is there is no complex conversion that is happening here, means we are easily converting this instruction to the hardware command without any problem, right? Without any complex things. Are we using any complex things to convert this to this? No, we are easily converting this. One instruction means here this instruction is one IO command. That is why we are saying there is a close correspondence between the instruction and the IO command, right? That is what that sentence means, and this is how you can map it easy. There is no complexity here, and there will be many IO devices connected through an IO module to the system. A typical computer system, has multiple IO devices. We know there are a lot of keyboard, mouse, printer, scanner, hard disk, USB. There are a lot of like this, lot of multiple IO devices are there. So each of these devices, it is basically connected to the CPU, memory and all. How? Through this IO module, right, which would act as an interface between this external device. So this IO module would act as a middleman between the CPU and the physical device. This we already know. The physical devices, there are multiple physical devices. This IO module would act as an interface between the CPU and the physical device. This point we already know. So we know many IO devices are connected to connected through IO module to the system. To the computer system, many IO devices are connected by the help of this IO module. Then we understood that. Then with this point we have already discussed that each of this device would has this unique address. That means keyboard, if you consider keyboard, would have a port address 0x60. It's a port address here. Similarly, and different devices, printer, different devices has its own port address. So just like every house would have a street address, a unique house number would be there, every IO device would also has this unique port address, so that CPU can identify it individually. So without this unique address, CPU could not or wouldn't know which device it has to talk to. So every device would have this port address for the CPU to understand it. With this only the CPU can identify it. Now, when the processor issues an IO command, the command contains the address of the desired device. Now, the processor, we have converted first the IO instruction. We got this IO instruction, software instruction, and we convert it into the IO command. This much we have done. Now, when the CPU wants to communicate with a specific device, okay, let's say if the CPU wants to communicate with one device, what happened is that it would send a command. Okay, a command would be sent. We know CPU would send the one IO command to the IO module to communicate. Now, along with that, it should also send this device's address on the address bus, like, hey, device at address 016, give me the last key pressed. Like that, we have to, if I want to get from the keyboard something, I would say the device at this address 0x16, I want to get the data from this address, means from the keyboard I need to get data. So in the address line, I would send the address also of which device I want to talk to. So through this address line, the address can travel. So this is what is happening here in our case where the IO when the processor issues an IO command, the command would contain the address of the desired device. Okay. So along with the command, you have understood that we will send the device's unique address also. Fine. Now let's understand here. This each IO module must interrupt the address line to determine if the command is for itself. That means every IO module would be constantly listening to this address bus. When the CPU sends out an address, each IO module check, is this address belonging to me? Okay, if yes, it responds and act on the command. If no, it ignores that command. That means what does the IO module do is that it can see, it is always plugged into the address lines, right? So it will always check this address line. If it see any address that is belonging to the IO module, then it will execute that command and it will act on that command. Otherwise it will ignore that command because that address is not there in the IO module, so it will ignore. So this is the address decoding which is happening in our IO module. It will see if this address is belonging to that IO module. If that address belongs to the device which is present in the IO module, then only it will act on this command. Otherwise it will ignore this command. This process is known as address decoding. So CPU if sent 0x0, then keyboard module would say, yeah, it is belonging to me. But printer module and disk module, no, because it's not belonging to their address. Because printer module is 0x378, let's say disk module is 0x1f0. So only keyboard will respond. So only keyboard module would actually act upon this command. Others would ignore that command. Understood? So here there are two modes of addressing are possible. There is memory mapped IO and isolated IO. There are two different strategies for organizing how IO device address are handled. How this IO devices are addresses and handled. Memory mapped IO means IO devices share the same address space as RAM. Isolated IO means IO device has their own address space. So memory mapped IO means these IO devices is sharing the same address space as in the RAM. Isolated IO means these are two modes of addressing which is possible. Okay. So these are the two different strategies for organizing how the IO device address are basically handled. IO device address handling thing we are talking. There is memory mapped and isolated IO. Memory mapped IO means IO devices are sharing the same address space. Isolated IO means they are having an separate address space. If the address space is shared with the RAM, then it is memory mapped IO. So there is memory mapped IO and isolated IO. This is the address mapping thing we are talking about. IO device addresses, how these IO devices address. What are the two modes of addressing? The two modes of addressing therefore are memory mapped IO and isolated IO. Now, if you see with memory mapped IO, there is a single address space for memory location and IO devices. That means, let's say in memory mapped IO, the total address space, this much address space is shared between the RAM and IO devices. So in the address space, some is for the RAM and some of the address spaces would be there for the devices, video control registers, keyboard registers, other IO devices and all. So IO registers of the devices are mapped into a specific memory address. The CPU doesn't know whether it is talking to RAM or device. It just uses the address. So RAM, there is a memory address space, but with memory mapped IO, the address space would be shared with the IO devices also. Here devices is there. So the CPU does not know whether it will talk to this RAM or device. It just uses the address. It only uses the address, nothing else. So you have to understand that in memory mapped IO, they do not have an isolated IO, right? Isolated address space. Here they are sharing the address space with whom? They are sharing the address space with RAM. So if the total address space is this much, if the total which is occupied, let's say by RAM, then you have to understand that rest of some spaces will be used by other devices. That is how the address space is divided. Okay. So the CPU doesn't know whether it is talking to the RAM or whether it is talking to these devices. It will just use the address to talk. Understood? Now the processor treats the status and data register of the IO module as memory location and uses same machine instruction to access both memory and IO devices. That means in memory mapped IO, we know IO module has data register and status register. Since these registers are mapped to memory address, the CPU uses this exact same instructions for both. That means here, if you see, the processor would treat this data register and this status register would have, like, they will treat like these have the memory locations, like modules as like memory locations. It will treat this data register and status register. So for instructions, they will use, for instruction they will CPU would feel that these are kind of memory locations, so it will use this to access. That means since these instructions are mapped to memory address, the CPU uses this exact same instructions for both. That means here move R1 comma 1, this address is given. This means it can be reading from RAM or a device register. Now this means could be writing to RAM or sending data to a device, right? So here the thing is that IO instruction, no special IO instruction is needed actually. Any instruction that is working with memory, like move, load, store, and all, are instruction that works with memory. It can also work with IO devices automatically, because in memory mapped IO, what happens is that the RAM's location and the devices are all sharing the same memory address space, right? So for IO instructions, we don't need special IO instructions here. Here, instructions that is working with memory, like move, load, store, and all, these are the instructions that is working with memory. They are not IO instructions, they are the instruction that works with memory. These instructions can also, it says that in memory mapped IO, these instruction can also work with IO devices also. That means whether this is a normal memory instruction, right? So we don't need special IO instruction, because here what happens is that this means I am reading from RAM or I am reading from a device, because the RAM and the device is sharing the same address space. So this particular instruction means I can read from RAM or I can read from the device, or cases happening. Whichever this address matches to, here this address is matching to what? Let's say video controller register. So that means it is going to read from the a device. Okay. So it is reading from a device. So that means we don't need special IO instruction. The normal our memory instruction is there, right? That instruction can be used to work with IO devices automatically, because the processor would treat this data register and status register of the IO module as memory locations and use the same machine instruction to access both the memory and IO device. That is, to access both memory devices, like to access both memory. That means we know CPU want to access the memory, as well as it may sometimes wanted to access the IO devices. So the same machine instruction can be used, like this instruction. We don't need special IO instructions. This same machine instruction can be used to access both this memory and IO devices. Why? Because the address space of because in memory mapped IO, we have to say why it is happening like that, why the same instruction can be used in both accessing from the memory and accessing from the IO devices, because both of the IO devices and the RAM is sharing the same address space in what? Memory mapped IO. and in here also the data register and the status register of the IO module, the processor would treat it like memory locations. Understood? So this is how the IO instructions are basically handled here. Okay, this is the case of this would be the case of memory mapped IO. Now in the case of isolated IO, if you understand, for the isolated IO we need what? Separate IO instruction, because here the RAM we cannot use our memory instruction because here it is not shared. So the address space for IO is isolated from that for memory. This is referred to as isolated IO. So in isolated IO is also called as port mapped IO. Here we have a separate memory address. Since it has a separate memory address, RAM has separate memory address, IO devices have separate. So we use in-out kind of instruction, you can see. So that means we will require special instructions for IO operation, and for memory instruction we require separate instruction. So that means in isolated IO where there is a separate address space, isolated IO is also known as what? Port mapped IO. So in isolated IO where there is a separate memory address space, here what happens is that there is special instruction using in and out. There is special instructions which is used. Dedicated instructions are there for what? Dedicated instructions are there for doing the the operations, IO operations, right? Memory instruction is separate, special instructions are there for IO. So IO instruction and memory instruction are separate here in isolated IO because the address space is separate. The RAM has different address space, IO devices have different IO space, as you can see here. Understood? But in the other case, in memory mapped IO, it was opposite, right? So this is what you have to understand about IO instruction. Thank you.